Welcome to Signals and System subject classes. Now we are in the first chapter, that is basics of the signals and system. In previous classes we have discussed about signal definition and signal representation, the types of the signals and the signal properties. You know the signal properties are time shifting, time reversal, time scaling properties. They are very important. After that we learned system importance and how to write the mathematical expression for the any system, and we learn the system properties. We have the 6 properties for the system. The first one is system with memory and without memory. We discuss in detail. I have given many examples for that. After that we learn invertibility, its importance of the invertibility, inverse system, invertible system. Is it checking the invertibility? The third one is causality. Causality is nothing but the output must be dependent on the input at the present and the past values of the time. Then it's said to be causal system. I have given many examples also. In fourth property, that is a stability. The bounded input, it leads to it produces the bounded output signal. Is it? If it follows the BIBO, it's said to be stable system. Then linear system, you know that to follow the linearity it should follow the scaling and additivity property, then it's said to be linear system. Then time invariant, it is nothing but the system behavior or characteristic are fixed over the time. It means the characteristic of the system never changes with respect to time. It maintains constant with respect to time. Then it's said to be time invariant. If the characteristic varies with respect to time, that is called time variant system. So now in this class we are going to discuss some problems. The first problem, let x of n be a signal with x of n equal 0 for n less than -2 and n greater than 4. It means it doesn't have the magnitude for this n values. So this signal having the magnitude from -2 to the 4. So it having the magnitude from -2 to the 4 only. For each signal given below, determine the values of n for which it is guaranteed to be 0. Is it? For the x of n minus 3, so for this 5 we should find the n values for which it would be 0. The magnitude would be 0. Is it? So first I am going to draw the first signal in example. So this is x of n. X of n is not given, just given only for out of the -2 and -4. So x of n versus n. So time values was 0. So 1 to, so it is having the magnitude from the -2. So in example I am taking any magnitude. So -2, -1, 1, 2, 3 and 4. So this is an example. So for n less than -2 there is no signal, and n greater than 4 there is no signal. Is it? So now I am going to draw the x of n minus 3. That is delayed signal of the x of n by 3 units. To draw that one, we need to shift the x of n to the right side by 3 units. So this is x of n minus 3 . So shifting this x of n to the right side by 3 units, then minus 2, 1, 2, 3. Is this minus 2? It will be appear at the 1. Is it? So it start from the here. So this is 1, 2, 3, 4, 5, 6, 7, and so on. 0, 1, minus 1, and minus. The next, this is value at minus 1, and I'm going to draw the value at 0. That is, it is appearing at the 3. 3, then so these are the values. So here, so n less than 1 and n greater than 7, it would be 0, is it? So we can write here, we can write, so this is delayed signal. So delayed signal, of x of n, is it? So x of n minus 3, this is a 0 for n less than 1 and n greater than 7, is it? And similarly, so 1, 2, 3, 4, 5. So minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, is it? So now this is the signal x of n plus 4. This is the advanced signal. So this x of n should be shifted to the left side by 4 units. 4 units. So this 4. So this magnitude. So this pulse it would be appeared at the 0. Is it? The top one. Is it? Next one. 3 are small. 3 are small. So this is the value at n equal 0, is it? That is appearing at the minus 4. Then small and bigger one. then we can write, after n less than minus 6 there is no signal, and n greater than 0 there is no signal, is it? That's directly. So this is a advanced signal. So advanced signal of x of n, is it? So write, so x of n plus 4. So this is a 0 for n less than minus 6 and n greater than 0. So this is a time reversal of x of minus n. First draw this one. So this is x of minus n. So this is a time reversal. Just to place the mirror on the y-axis, then take the mirror image, is it? So it start from the minus 4 to 2. 1, 2, 1, minus 2, minus 3 and minus 4. Minus 3 and minus 2 and minus 1, 2 and 0. So in reverse, this 4 will be appeared at minus 4. Is it? Remaining 3 are small. So from the observation, so n less than minus 4 there is no signal, n greater than 2 there is no signal, is it? So these are the zeros. So x of minus n that equal to 0 for n less than minus 4 and n greater than 2. So this is delayed signal plus 2 minus, so time reversal, this is the delayed signal. So delayed of x of minus n, is it? So delayed by 2 units. Just shift this x of n minus x of minus n to be shifted to the right by 2 units, is it? So this is to be shifted to the right side by 2 units, is it? So this minus 4 value, this impulse at the minus 4, it must be appeared at minus 2, is it? So it doesn't have the magnitude from n less than minus 2 and n greater than 4, is it? So that's Here I am going to write here. So this x of minus n plus 2, this is a 0 for n less than minus 2 and n greater than 4. So this is the advanced signal, advanced of x of minus n. Then, so this x of minus n minus 2 equal 0. So this is advanced signal. So to be shifted to the left side. So subtract 2 from the this, is it? So this is the x of minus 1, subtract 2, is it? Then subtraction, then so n less than minus 6 and n greater than 0, subtract, is it? Just subtract. Subtract, this is minus 2, here minus 2. Then you will get the x of n values for the x of minus n minus 2. So this is about this problem. Then we go for the next problem. Here, determine whether or not each of the following signal is periodic. Is it? The first one, so this is x1 of t, this is 2 into, so I am going to expanding this one, e power jt into e power j 5 by 4 into e of t, is it? So this is a constant, so these are constant. So in the simplification, 2 into e power j pi by 4 into e power j into t, so multiplication, again multiplication u of t, is it? So this is the constant, is it? So this is signal, so it is also signal. So this is periodic, in continuous time it is a periodic, is it? But this is aperiodic signal. Why? Because this is unit step is aperiodic. You know why? So u of t, that is having the value 1 for t greater than 0. For in case of discrete, n greater than or equal to 0, is it? This is 0 for the t negative values. So this is aperiodic, this is a periodic. You know the multiplication. You know this, if u of t is multiply this signal, periodic signal, what will happen? The period is, we will get the cycles for the positive values only. Why? Because u of t having the magnitude for positive values, is it? It doesn't have the magnitude for negative values, is it? Then this periodic, it goes to aperiodic, is it? So overall, so this is aperiodic signal, is it? The second one, so discrete signal is given, that is x2 of n equal to u of n plus e of minus n, is it? So I want to explain with the help of the diagram. So the first one is u of n. So u of n, it start from the 0, is it? It start from the 0. So E of minus n add this two addition, is it? So 1, 2, 3, 4, 5, 0, minus 1, minus 2, minus 3, up to dash, 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 is it? So at 0 also, at 0, see, so addition, so the resultant must be have the values for the positive and negative. But in observation, so at 0, 2 are providing 1, 1 unit, then 1 plus 1, 1 plus 1, it becomes 2. So at 0, that is it? Except n equal 0, it is having the 1 unit, is it, from minus into infinity, except 0, is it? So it is only providing 2 units magnitude, is it? Then it is not a periodic, it is a aperiodic signal. Third section. So now we are going to draw the x3 of n. X3 of n, is it? So first, so in this equation, k, so the signal, it is depending on the k values, is it? So k from the minus into infinity, is it? So first of all, we have to check it for all values, first all values of k. So that's for that I am going to substitute k equal 0, the initial one, is it? For k equal 0, I am going to check it what is the signal, is it? So after substituting k equal 0, del of n minus 1. So del of, so del of n minus 1, is it? So this is a signal del of n, this is minus del of n minus 1. Because of minus, I have drawn to the downside, is it? Then next substitute k equal to 1, del of n minus 4, here minus del of n minus 1 minus 4. So resultant del of n minus 5, is it? So this is one value, 2, 3, 4, is it? So 2, 3, 4, 5, 6, 7, 8, 9. So 5, 6, 7, 8, 9, is it? So for the k equal to 1, del of n minus 4, del of n minus 4. So impulse, delayed impulse by 4 units, is it? Next, minus del of n minus 5. Minus del of n minus 5. So magnitude is reversal, and is it? So we can write this is del of n minus 4. So this is minus del of n minus 5. Is it? Now again substitute k equal to 2. So del of n minus 8 minus del of n minus 9. Is it? So one impulse at the 8, one negative impulse at 9, is it? So we can write this is del of n minus 8, this is minus del of n minus 9, is it? Again for this negative values, I am going to substitute k equal to minus 1. So del of n plus 4 minus del of n plus 5, is it? These two are the advanced impulse signals, is it? So one impulse at the 4 and one impulse at del of n minus 1 plus 4, that equal to del of plus 3. So minus 1, minus 2, minus 3 and minus 4. So substitute k equal to minus 1 del of n plus 4. So advanced impulse signal by 4 units. The next k equal to minus 1 del of n minus 1 plus 4. So then resulted del of n plus 3. That is having the magnitude negative. So that's we should draw downside. So this is del of n plus 4, advanced signal of del of n, is it? This is del of n plus 3. So this is a cycle. What is this? So this cycle is repeating every 4 seconds, is it? So this is a periodic signal. So this is it is only periodic. So periodic, the time period equal to 4 seconds, is it? Next problem. So determine whether or not each of the following signal is periodic. If a signal is periodic, specify its fundamental period, is it? The first one, this is continuous signal is given j into, this is the magnitude e power into j into 10 into t. So there is no problem. In continuous time it is a periodic signal, there is no doubt. So time period equal to, so this is omega naught, so 2 pi by omega naught, that equal to 2 pi by the omega naught value equal to 10, so that equal to 5 by 5 seconds, is it? So this is a periodic. So this is the periodic signal. Periodic, the time period equal to 5 by 5 seconds. And fundamental frequency 10, is it? Next one, so B, so x2 of t, so expand the signal minus e power minus t into e power minus j into t, is it? So this is the signal, this is the signal, is it? So both are signal, but the first one is a periodic signal, it is not periodic, but complex number is a periodic. Complex exponential signals all are periodic signal, is it? So periodic multiplication, it goes to aperiodic, it is? So this is aperiodic. For aperiodic there is no time period, is it? So the next problem, that is given x3 of n, this is a discrete time signal, that equal to e power j into 7 pi n, is it? So discrete, there is no signal multiplication. So this omega naught equal to, it is not fundamental frequency, that's you should remember, 7 pi. So this is a periodic. So time period equal to 2 pi by omega naught 7 pi into m. So pi gets cancelled, is it? So this is pi gets cancelled. So 7 must be cancelled. So that's why we should take m equal to 7. So this, okay. Then the resultant, so n equal to, we are getting 2. So you know why we are taking m, I already have given the information. So in discrete signal it is defined for the integer values of the time, then the time period also integer value, is it? So fundamental frequency, formula 2 pi by, is it? So 2 pi by n equal to 2 gets cancelled pi. Or we can write fundamental frequency equal to omega naught by m. Is it? So this is a periodic. So the time period n equal to 2. So next problem, x4 of n that equal to 3 into e power j3 pi n into e power j3 pi into 5 by 2. So this is the constant. Into e power j 3 pi n, is it? So this is the constant. So this is the signal. So it is signal, it is a discrete, it having the pi, so this is a periodic signal, there is no doubt. So fundamental time period equal to 2 pi by, so 3 pi into m, so pi gets cancelled. To get the cancel 3, we should take m equal to 3, so 3 gets cancelled, then n equal to 2. So this is the periodic, that n equal to 2. The last problem, x5 of n so this is a constant, so this is a signal, is it? So I'm going to find the time period, so 2 pi by 3 into 5 into m. If I take the m equal 3, then I'm getting 10 pi, but it is not integer, is it? So this is aperiodic. So here next, determine the fundamental period of the signal x of t. This is the sum of the two signals, is it? So x1 of t, it's a time period t equal to 2 pi by 10, that equal to 5 by 5. So this is the t1, is it? Next t2, 2 pi by 4, that equal to 5 by 2. So for the fundamental period of the x of t, so this is about to x2 of t, is it? So t equal to LCM of t1 and t2. So that equal to LCM of 5 by 5, so 5 by 2. So these are the and in the fractional number, so LCM is nothing but common factor. So the common factor, so 5 2 are the prime numbers. So x at pi, there is no common, so pi is the common, so t equal to pi, is it? So this is the time period, so time period equal to pi. LCM of 5 by 5 and 5 by 2. In fractional number, just you take the common factor. Common factor is nothing but LCM. So determine the fundamental period of the signal x of n. The signal is given in the discrete. These are the sum of the three. So first n1, first signal, it is a periodic signal. The time period equal to 1, is it? Having the magnitude for all values, is it? The second one, n2 equal to 2 pi by 4 pi into 7, is it? Into m. So pi gets cancelled, 2 gets 2. So pi gets cancelled, 2 1 ja, 2 2 ja. So we should take m equal to 2 gets cancelled, then here we are getting 7, is it? So n3 equal to 2 pi by, so 2 pi to 5, is it? So 2 pi gets cancelled, then you are getting 5, is it? So fundamental time period of the x of n, that equal to LCM of 1 comma 7 comma 5, you know, the least common factor, that equal to 35. Next problem, consider the discrete time signal x of n equal to 1 minus sigma k equal to 3 to del of n minus 1 minus k, is it? Determine the values of the integers m and n naught so that x of n may be expressed as x of n equal to u of capital M n minus n naught. So this is a x of n. In first case it is denoted in terms of the impulse. In the second case it is denoted by the in terms of unit step. So we need to convert the impulse to the discrete. First I am going to draw the first one signal. Then second signal, third signal. So this is the one signal. So one signal having the magnitude for all values, is it? So 1 2 3 4 5 minus 1 minus 2. This is a second signal. I am taking this is x1, this is x2, is it? So this is a x2 signal, is it? So in x2 this k equal to 3, it started from the 3, is it? Substitute n minus 1 minus 3, so n minus 4, is it? N minus 4. So it is starting from the 4 to the infinity, is it? So signal up to infinity, is it? 4 5 6. Minus 1 minus 2 minus 3 and minus 4. There is no signal, is it? Now this is x of n. Now do the subtraction, is it? Subtraction between this, is it? This is x1, is it? Then so it is having the minus into infinity. subtracting these values 4 to the infinitive, so all 4 to the infinitive gets cancelled, remaining, so minus infinity to up to 3 we will get it, is it? So minus 3 minus 3 minus 2 minus 1. But there is no signal, is it? It 4, that is 0, is it? 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, and minus 4. Is it? So this signal we can write x of n equal to, this is a unit step, so reversal, so reversal and shifted to right side, is it? Delayed signal entry, delayed signal we can write e of minus n in delayed, that is plus how many times? 3, is it? So this is called delayed of e of minus n by 3 units, is it? Then compare this with the question. So m equal to minus 1, n naught equal to minus 3.